And that's how millions of cakes are made, from raw materials to the final product. And that's how millions of cakes are made, from raw materials to the final product.
In the quiet hours before dawn, a sleeping giant begins to stir, preparing to feed a nation's appetite for sweetness.
Every day, 40 tons of premium wheat flour are inhaled by the facility's pneumatic nervous system.
Liquid ingredients are stored in a state of suspended animation, kept at precise temperatures to ensure bacteriological safety.
Logistics are just as crucial as chemistry. A single missing ingredient could halt the entire production line.
Before a single mixer turns, samples are subjected to rigorous scrutiny to guarantee consistency down to the micron. This is the mixing hall, where raw elements will soon be transformed through kinetic energy and precise timing.
To ensure a perfectly airy crumb structure, the flour is sifted and aerated immediately before mixing.
Solid blocks of shortening are extruded under immense pressure, preparing them for the emulsification process. Every morning, the facility consumes enough raw ingredients to fill an Olympic swimming pool.
Before a single human hand touches them, these ingredients are sorted by an automated nervous system.
Technicians verify purity at the molecular level before the batch is cleared for production.
Chemistry is the first step in the baking process, ensuring consistency across millions of units.
Hygiene protocols here rival those of a hospital operating room.
From this nerve center, a single operator can control the flow of ingredients for the entire plant. With the lines cleared and prepped, the main production cycle is ready to engage.
The process begins with a precise blend of dry ingredients, aerated to ensure a perfect crumb structure.
Volumetric pistons deposit the batter with gram-perfect precision, ensuring consistent density across millions of units.
Entering the thermal tunnel, the batter is subjected to a carefully staged heat profile designed to activate the leavening agents immediately.
Inside, convection currents circulate air at 350 degrees, triggering the Maillard reaction that gives the sponge its golden hue.
Emerging from the oven, the cakes release steam instantly, locking in the moisture content required for a prolonged shelf life. Vacuum grippers gently lift the sponges from their molds, a delicate operation performed at high speed to clear the line for the next batch.
The cakes embark on a mile-long journey through the spiral cooling tower, bringing their core temperature down to ambient levels.
Ultrasonic blades vibrating at 20,000 times per second slice the sponge cleanly, eliminating crumbs and ensuring a perfect surface for the filling.
Automated manifolds apply a continuous ribbon of buttercream, calibrated to exactly 12 millimeters in thickness before the top layer is sealed.
Entering the direct gas-fired tunnel oven, the batter is subjected to a precise thermal profile designed to activate the leavening agents immediately.
Ribbon burners maintain a consistent temperature of 210 degrees Celsius.
To ensure rapid expansion of carbon dioxide creates the sponge's cellular structure, which must set before the proteins fully harden.
In the final heating zone, the Maillard reaction caramelizes the sugars, creating the golden crust. Exiting the oven, the cakes undergo immediate thermal shock, releasing steam that helps separate the sponge from the metal pan walls. Vacuum depanners use low-pressure suction to lift the delicate cakes without crushing them, processing over 1,200 units per minute. To prevent condensation in the packaging, the cakes travel 2 kilometers on a spiral cooling conveyor, dropping their core temperature to ambient levels.
Optical sensors scan for alignment and structural integrity, instantly diverting any product that doesn't meet the strict dimensional specifications. Entering the tunnel oven, the batter encounters a consistent 350 degrees, triggering the leavening agents instantly.
Inside the convection chamber, the Maillard reaction browns the crust, while the internal starch matrix gelatinizes to set the structure.
Emerging from the heat, the cakes undergo immediate optical inspection to verify height and color uniformity.
To prevent condensation shock,
the cakes traverse a vertical spiral cooler, dropping their core temperature over a 20-minute cycle. Vacuum-assisted depanners gently lift the sponges from their molds, relying on precise suction to avoid damaging the delicate crust.
The empty pans are immediately routed through a high-pressure wash cycle, stripping away grease and crumbs before reuse.
Volumetric pistons inject exactly 15 grams of cream filling, monitoring back pressure to ensure the cake's structural integrity remains intact. Before enrobing, a vibration table settles the filling, while optical sensors reject any cakes showing signs of surface rupture. Once deposited, the batter begins its journey through a 100-foot tunnel oven, where precise thermal zones initiate the rise. Inside, convection fans circulate hot air to ensure an even bake, transforming the liquid batter into a solid sponge structure.
At the peak of the baking cycle, the Maillard reaction occurs, giving the cakes their signature golden crust and rich flavor profile.
Emerging from the heat, the cakes are fully formed, but they are too fragile to be handled immediately.
A rapid cooling phase is essential. Industrial fans strip away surface heat to stabilize the crumb before extraction.
Vacuum depanners gently lift the cakes from their trays, using precise suction to avoid damaging the delicate surface.
The empty pans are immediately routed to a high-pressure washing tunnel, ensuring a continuous sanitary loop for production.
To reach ambient temperature, the cakes ascend a massive spiral cooling tower, traveling over 1,000 feet without leaving the room.
Entering the thermal tunnel, the batter encounters a carefully calibrated heat gradient designed to trigger immediate expansion.
Inside the chamber, convection fans circulate superheated air, setting the crumb structure and ensuring uniform rise across millions of units.
As the sugars caramelize, the Maillard reaction creates the signature golden crust, locking in moisture before the cooling phase begins.
Emerging from the tunnel, the cakes release steam as they face the critical transition from baking to cooling.
Pneumatic suction heads lift the delicate sponges from their pans, separating the product from the tooling with vacuum precision. The empty pans are immediately blasted, scrubbed, and dried, returning to the start of the line in a continuous sanitary loop.
To stabilize the structure, the cakes ascend a massive spiral cooling tower, traveling over a mile of belt space without leaving the room.
Laser scanners and human eyes perform a final quality check, ensuring only structurally perfect cakes proceed to the decoration stage.
To prevent condensation and ensure a clean slice, the cakes must travel 2 caphometers on a spiral conveyor to reach optimal temperature.
Ultrasonic blades vibrate at high frequencies to slice the delicate sponge, creating a perfectly level surface for the filling.
Automated nozzles spray a precise mist of simple syrup, locking in moisture to extend the shelf life of the final product.
Volumetric depositors inject the exact gram weight of buttercream, maintained at a specific viscosity to prevent runoff.
High-speed Delta robots align the top layers with millimeter precision, sandwiching the filling to complete the core structure.
Spinning pedestals allow stationary blades to apply a thin crumb coat, sealing the sponge before the final decoration stage. Before the final decoration, a nitrogen flash tunnel rapidly cools the exterior, solidifying the structure for complex icing designs. Exiting the oven is only the beginning. The sponge must be brought to a precise 22 degrees Celsius before any filling can be applied.
To ensure uniform stacking, automated levelers shave off the crown of the cake, exposing the porous structure beneath. A calibrated mist of simple syrup is atomized onto the sponge, locking in moisture and extending the product's shelf life. Automated depositors lay down a continuous ribbon of filling, calibrated to weigh exactly 100 grams per linear foot. Vacuum arms lift the top sheet and place it with zero-tolerance alignment, creating the classic sandwich structure. Before cutting, the cakes ascend a spiral blast chiller, cementing the bond between sponge and cream. Ultrasonic blades, vibrating 20,000 times a second, slice through the sticky layers without leaving a single smear.
Vacuum depanners utilize precise air pressure to lift the fragile sponges without damaging their structural integrity.
Before finishing can begin, the cakes must travel 2 kilometers on a spiral conveyor to reach room temperature.
Ultrasonic blades vibrate 20,000 times a second to ensure a crumb-free cut for the layering process. Piston fillers deposit a measured amount of buttercream, calibrated to the gram to ensure uniform sweetness.
The enrober recirculates hundreds of liters of chocolate, maintaining a constant temperature to prevent premature crystallization.
Liquid nitrogen heat exchangers drop the ambient temperature instantly, locking in the chocolate's glossy finish.
Delta robots execute complex piping patterns faster than the human eye can track, decorating 500 cakes per minute.
Vision systems analyze color, shape, and volume, rejecting any product that deviates from the standard by even 1%.
At the enrobing station, a continuous cascade of ganache coats each unit, with air knives precisely calibrating the thickness to within a single millimeter.
Counter-rotating rollers polish the surface, ensuring that every cake meets the strict visual standards required for supermarket shelves.
Titanium blades, vibrating at ultrasonic frequencies, slice through the layers without friction, preventing the cream from smearing or sticking to the metal.
Delta robots execute the finishing touches, depositing decorative rosettes with a speed and consistency no human hand could ever match. Vibrating hoppers distribute the final garnish, while vacuum recovery systems below ensure that any excess material is collected and recycled.
Laser scanners map the topography of every cake, instantly rejecting any unit that deviates from the programmed symmetry by even a fraction of an inch.
Once approved, the stream of cakes diverges into multiple lanes, automatically sorted and routed toward the packaging department.
Before boxing, the cakes pass through a nitrogen tunnel, flash cooling the exterior to lock the decorations in place and prevent damage.
The enrobing curtain operates at a strictly controlled viscosity, ensuring a uniform shell that seals moisture within the sponge matrix.
Inside the cooling tunnel, thermal shock is applied carefully to crystallize the coating without blooming the chocolate.
Multi-axis robots apply the signature garnish, utilizing optical triggers to match the line speed with millisecond latency. Vibratory feeders distribute the final textural elements, calibrated to deposit exactly 3 grams of garnish per unit.
Titanium blades vibrating at ultrasonic frequencies slice the product cleanly, preventing the cream layers from smearing. Smart conveyor systems singulate the product flow, dividing the bulk output into 6 independent packaging streams. Density-detecting X-ray scanners inspect every slice, instantly rejecting any product containing foreign materials.
Nitrogen flushing during the flow wrapping process displaces oxygen, significantly extending the shelf life of the final product.
To ensure a uniform finish, the phonomet is recirculated constantly, maintained.
Sensors trigger the garnish dispensers with millisecond accuracy, minimizing waste and ensuring every cake meets the visual standard.
Ultrasonic blades vibrate 20,000 times a second, allowing them to slice through the sticky layers without dragging or deforming the cake.
Acceleration belts pull the portions apart, creating the precise spacing required for the high-speed wrapping machines ahead.
Before packaging, high-speed cameras analyze every square inch of the product, checking for defects invisible to the naked eye. Any cake that fails to meet the strict specifications is instantly removed from the line by pneumatic actuators. Entering the flow wrapper, a continuous roll of film is formed around the cakes, creating a protective tube without smudging the icing.
Heated crimping jaws seal and cut the packages at a rate of 300 per minute, locking in freshness instantly.
Automated palletizers build structurally sound stacks, wrapping them in tensioned polymer to prevent shifting during transit.
Laser-guided vehicles transport the finished pallets to the cold storage facility with millimeter precision.
To preserve freshness, the cakes enter a deep freeze environment, halting the aging process immediately. High-density racking systems allow the facility to store weeks of production inventory in a climate-controlled state.
Distribution logistics are coordinated to the minute, ensuring trucks are loaded and dispatched without delay.
Maximizing trailer capacity is essential for reducing the carbon footprint of the distribution network.
As one shift ends, the fleet departs, carrying millions of servings to supermarkets across the country.
And that's how millions of cakes are made, from raw materials to the final product.
Finished pallets are immediately transferred to the deep freeze warehouse, where temperatures are maintained at a critical -20 degrees Celsius to lock in freshness.
Advanced optical character recognition systems track every single box, ensuring 99.9% inventory accuracy before the product leaves the
Logistics teams work in tight coordination with the production floor, loading refrigerated trucks in a precise sequence to maintain the cold chain.
Every night, a fleet of temperature-controlled vehicles departs the compound, distributing the day's yield to retailers and distribution centers across the continent. Rigorous sanitation protocols are executed during shift changes, ensuring that the equipment is pristine and ready for the next production cycle.
As the sun rises, raw materials arrive at the intake bays, replacing what was just shipped out, completing.
And that's how millions of cakes are made, from raw materials to the final product.